In this complexity section, complexity is an algorithm is the function of fn which gives the meaning of time or storage space required for the data to be processed. That means you are running a program. What amount of data and time is required will compare to the complexity unit. Here we have two types of complexity, space and time. In space, we have instruction space, data space, and environmental stack space. In the time complexity, we have constant time, latency, linear, quadratic, cubic, and exponential time complexity. Here we have description about constant time. Then the linear one. Then the logarithmic time. You may see that their formulas are different from each other. Lastly, quadratic time, then the cubic time, and then exponential time. Those time measures are important in the algorithmic view. In some time in Viva, they can ask you about those timing algorithms. You can have a snap of this one. Now we're in the asymptotic notation. Here we have three notations. First one is the big O notation. Here is the figure of diagram about the big O notation. Here we can see it is not symmetric and the value is O into n to the power 2. Here is the example of big O notation. Now we are in the big omega notation. Here we have some description about big omega notation and that function gn is a lower bound for this function. Here is the diagram and example of the big omega notation. Now the big theta notation. Here we have some description and the diagram of big theta notation. Here we have the example. Analysis of algorithm. In this analysis section you can have the worst case, that means here complexity is high. In the best case, in the runtime complexity is above to null. In average case, the running time complexity is in medium section. And amortizing in runtime, here algorithm function defines by sequence of operation applied to input size and the average over time. Here are the description of each case and also their complexities are given here. Repeating again, those complexities are very important for your examination and Viva. Here we have the recursive function. Recursive function is that type of function that means that function is calling own function again and again. Here we have a recursive function, and in this function we have again that recursive function. That means this function is calling this function again and again, and it creates a loop. That is how a recursion function works. Here is the recursive algorithm. The direct recursive algorithm is given here. Now, the indirect recursive algorithm. The difference between direct and indirect recursive functions are given here. This one is for indirect recursive function. Here we have m1 to m2, then m3 is directly connected with m1, m2 and m3, then again m1, m2 and m3. Here this connection is indirective recursion. You can have a snap of these points. No more today. Thank you.